Brad Williams, Frugal Finance. So far, we've seen how to immunize FSF against changing interest rates, which amounted to setting the duration gap to zero. Let us now assume that FSF wants to reduce but not eliminate the interest rate risk inherent in the firm's operation. FSF management decides to make the firm behave like a bond with the duration of 1 year instead of behaving like a bond with a duration equal to the firm's duration gap of 2.39. In general, we can use swaps to set the duration gap of the firm to any desired level as follows. D of G is equal D of G plus D of S, market value, total assets, where D star G is the desired duration gap. D of S is the duration of the swap, and MV, required market value, notional principal for the swap. To set the duration gap of the firm's interest-sensitive assets to 1 year, required solution is as follows. D star G is equal to D of G plus D of S. Market and assets equals 2.39 plus 5.15 MV of H minus 155 MV of H equals 1 minus 2.39 times 155 divided by 5 is going to equal negative 42,137,025. Pay fixed swap. Got that? The negative sign on MVH indicates that a pay fixed swap is required. If one were sure that a pay fixed swap would be required, the sign for DS would be shown as negative, reflecting the duration of the pay fixed position. The results makes common sense given what outputs we've already seen. The duration gap of the firm was 2.39 initially. In this position, combined with the pay fixed swap having a notional principal of 72, moved the duration gap of the firm to zero. Changing the duration gap from 2.26 to 10 alters it by 58%. 1.39, divide this by 2.39. Not surprisingly, the necessary swap position is 58.2% as large. 42 divided by 72 as the swap necessary to move the duration gap to zero. With a duration gap greater than zero, the firm's value is exposed to the danger of rising interest rates. If the firm expects rates to rise and wishes to speculate on that eventuality, it might wish to set its duration gap to less than zero. For instance, a modest speculative position could be achieved with the duration gap of 0.5% or half a year. The swap position to achieve this exposure would be the same D of G equals half year equals DG plus D of S. So we're going to have 2.39, 5.15, market value 155 equals negative 0.5 minus 2.39 times 155, 5.1. We're going to have this formula, and then we have 87.4. And that would be our pay fixed swap is required. We have 84,70406. So a pay fixed swap with a notional principal of 87.4 million is required to change the duration gap to 20.5 years. This procedure moves the duration gap of the firm from its original position value of 2.39, indicating an exposure to rising interest rates, beyond the risk neutral duration gap of 0 to a negative duration gap of 20.5. Now, if rates rise, the firm will benefit. However, it is exposed to losses if rates fall. Finally, we consider how swaps can be used to make an extreme speculative position for FSF. A duration of 10 years would be an extremely large duration for any bond in the market, indicating a large sensitivity to rising interest rates. FSF could use a swap to create this position with startling ease. Applying the same formula, the solution would be as follows. D of G equals 10 equals D of G plus D of S, market value, total assets. 2.39 plus 515 MB of H, 155. MB of H equals 10 minus 2.96201 times 155 divided by 5.15 gives you this 229. The right here is this number right here. To change the duration gap for the firm from 2.39 to 10 years, the firm would enter A received fixed swap with a notional principal of $229 million. We have seen that a pay fixed swap of modest proportion reduces the interest rate risk of FSF. A receiver fixed swap increases the duration gap for FSF. These examples emphasize the power and flexibility of swaps for changing the interest rate exposure of a firm. The risk of extreme position should not be neglected either. A formula for the approximate price change of an interest rate sensitive asset is as follows. We have the change in P, approximately D change in, looks like the yield to maturity, divided by 1 plus 8, and we've done this before, where D is expressed in years. A, YTM is an annual yield to maturity on the asset, and P is the current price of the asset. If FSF were to set its duration gap to 10 years, its net worth would be extremely vulnerable to interest rate risk. Taking the average rate on all FSF positions at 7% for convenience, we see that an interest rate increase of only 10 basis points would cost FSF almost $152,854, which is about 1% of its net worth of $16.3 million. Here it is right here, 10 times 0.001 divided by 107, 152,000. 10 times 0.01, 152,854. A major rise in rates, say an increase of 5 percentage points, would cost FSF $7.642 million, or 46% of its net worth, if SFS duration gap were set to 10 years. Swaps, like other powerful tools, require caution in their use. Be extremely careful when a bank salesperson walks into your office and say, "Hey, FSF, we have this duration gap formula, and it's going to just do wonders for your company." And you're going, well, sounds great. Why don't we put it in place? And you didn't crunch these numbers. Well, swaps, like other powerful tools, require caution in their use. Brad Williams, Frugal Finance. Thanks for watching.